Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 3.7 entitled Formulas. And today we're going to solve a formula for a given variable. And then we're also going to use some formulas in application settings in word problems. And a formula is an algebraic equation that relates two or more quantities. And you actually know a lot of formulas already. We've worked with distance equals rate times time. You know area. Area of a rectangle or a square is length times width. Area of a triangle is 1/2 times the base times the height. You might know the area of a circle, pi r squared. You might even know circumference of a circle, 2 pi r. We've worked with perimeter, and there's an equation for perimeter of a rectangle. Oops, not 3. It's 2 times the length plus 2 times the width. You might also know volume, length times width times height. And there's a lot of science formulas that get used in work, or in math a lot, like the work formula. Work equals force times distance. There's interest. Interest equals your principal times your rate times your time. Okay. So there's lots of different formulas, and you might know more than these, but these are just some examples of some different formulas. Now, what we're going to be doing today is we're going to be solving a formula for any quantity that's in it, so for any of its variables. So if we just had distance equals rate times time, we could resolve this equation so that it's not solved just for distance, it could be solved for rate or for time. So if I was going to solve this for rate, I would have to divide by the t. So I'd have distance over time. Or if I wanted to solve it for t, I would have to divide by the r. So I'd have distance over rate. Same thing for, I don't know, area of a circle. Area equals pi r squared. If you wanted to solve that for the r, you would have to divide by the pi, and then you'd have to take the square root. So you'd have the square root of the area divided by the pi. We could even do circumference, 2 pi r. If you want to solve that for the radius, you'd have circumference divided by 2 pi. Okay. The work formula, we could do one more. Work equals force times distance. So we could, again, solve that for F. So you'd have work over distance, and then you could have it solved for D, W over F. So this is what we're going to be doing today. We're going to be talking about how we can solve a formula for any of the variables that are in it. Okay. Now, for in example 1, it says to solve the formula for the specified variable. So sometimes when this is written in your book, it looks a little funny. Don't be confused by the notation though. After the word for is what you're solving for. Everything else that comes in front of that, that's your equation or your formula. Okay? So in part A here, we're going to be solving area equals 1/2 times base times height for height. So I want to get this h by itself. So it's just like if there were numbers and h was the only variable, I'm going to undo everything that is in that problem that's attached to the h. So the stuff that's attached to the h is this being multiplied by b and being multiplied by 1/2. Now it doesn't really matter which one we get rid of first, but I really am uncomfortable with that fraction. I want to get him out of there. I don't want to have to deal with a fraction longer than I need to. So I'm going to divide by 1/2. But remember, we never divide by a half. We never divide by a fraction. we multiply by the reciprocal. So I'm going to multiply both sides by 2. And let me just write it over here, I guess. Times 2 over 1 times 2 over 1. So then the 2 and the 1/2, they're going to cancel each other out. And now I have 2 times a, so I have 2a equals base times height. Now I'm still trying to solve for h. H isn't completely by itself yet. So to get it by itself, I'd need to divide by b. So now I have h equals 2 times the area divided by the base. And if I had the formula written this way, I could solve any problem for the area of a triangle. If I knew the area and the base, I could easily plug those numbers in and solve for the height. So it's really good to have the formula set up for what you're trying to solve for first. Then you can just substitute in the values that you know and simplify to get your answer. Okay, now part B is a little trickier just because it looks more complicated. Again, we have another fraction, we've got some parentheses, we've got subtraction and addition, so it seems like there's a lot more going on in this problem. But again, we're going to read what they want us to solve it for. So you have k equals 5/9 times f minus 32 plus 237. And we're going to solve that for f. Now this is really the formula for converting Fahrenheit to Kelvin. So this is a way to convert temperature. But you don't have to know what the formula is in order to solve it for f. Now here's f. F is all the way inside these parentheses. So if I'm going to eventually solve for f, I've eventually got to get the parentheses by themselves. And I have a number that's being added. I have the 273. And then I also have a fraction that's being multiplied by it. Now, if I was solving a traditional two-step equation, if I had to choose between multiplication and addition, I would undo that addition first. So that's what I'm going to do here, minus 273 to both sides. Now I can't really do k minus 273, so I'll just write k minus 273. And then I bring everything else down. Now I'm still trying to solve for f. F's right there. And I know that there's that subtraction inside the parentheses, but it's inside the parentheses, so I got to save that for later, okay? When we are solving an equation, remember we're doing the opposite of PEMDAS, so I got to work backwards. I did the addition and subtraction. Now I've got to do the multiplication and division until I say, and then I save the parentheses until I get to the end, okay? So I have to get rid of that timesing by 5 over 9. So I would divide by 5 over 9, but we never divide by a fraction, so I'm going to multiply by 9/5. Now, on this side of the equation, on the left side, there's really two things that I'm multiplying by 9/5, the k and the minus 273. So I'm going to put the whole thing in parentheses to show that I want to multiply everything by 9/5. Now really over here, the 9/5 and the 5/9, they cancel. So now I have the f minus 32. So finally, I have that stuff that was in the parentheses by itself. It all popped out. So now I'm still trying to solve for f. I have one last step to do. I just have to add the 32 over to the other side. Now I know that 273 and 32 are both numbers, but this 273 is being subtracted from the k. He's inside those parentheses. So I'm not really going to add them together. Okay? I'm going to write the 9 over 5 times k minus 273. And then I'm just going to put the plus 32 at the end. Whew! There we go. I have f solved for now. So now if I am given a Kelvin temperature and I'm trying to convert it into Fahrenheit, this equation is already solved for Fahrenheit. So I would just have to plug my number in for K, subtract 273, multiply by 9/5, and add 32. The last one here, part C, says to solve that equation, P equals 2L plus 2W for W. This is a lowercase l. I know it kind of looks like a 21. It's meant to be a lowercase l. So I'll write over it. So again, I'm solving for W. So this is my equation now, and I'm solving it for W. So if I want to get the W by itself, I'm first going to have to undo this addition. And the stuff that's being added is the 2L. So I'm going to have to subtract the 2L on both sides. And again, I can't combine like terms on the left side because the P and the L aren't like terms. Okay, and now my last step to solve for W is going to be to get rid of that timesing by 2. So I divide by 2. I have to do everything over on this side of the equation. So I'm going to have then for my final equation, W equals P minus 2 times L all over 2. So that problem wasn't nearly as complicated as part B. I think part B is definitely the toughest one. Whoops, I forgot example 2. Let me go back. There it is. Okay, so now example 2 and example 3, these are word problems. So let's read what example 2 says. It says to solve A equals L times W for W. Then use the new formula to find the width of a rectangle that has an area of 42 feet squared and a length of 6 feet. So here's my equation that they gave us, area equals length times width. They want me to solve that for W. So if I'm trying to get the W by itself, I'd have to divide by the length. So W equals area divided by the length. So that's my new formula. So now that I have that new formula, I'm going to find the width. Oh, good, that's what I have this equation solved for. So find the width, that's what I'm finding, of a rectangle that has the area of 42 feet squared and a length of 6 feet. So I'm going to take this equation, W equals my area is 42 and my length is 6. 42 divided by 6, that's 7 feet. Now we could solve this problem using just area equals length times width. If they tell you the area is 42 and the length is 6, you're still solving for this equation for W. So you would divide both sides by 6 and you still get 7. So all we're really doing, instead of plugging the numbers in first and then solving, is that over here we're solving first for W and then we're plugging the numbers in. So it's 2 ways to get the same answer. Okay, example 3, last one. Voyager 1 was launched into space on September 5th, 1977. It reached Jupiter on March 5th, 1979. The average distance from Earth to Jupiter is 390 million miles. At what rate did Voyager 1 travel? All right, so first thing we have to do is we have to figure out how much time has gone by. Okay, so we started with a launch into space on September 5th, 1979 or 77, and then it reached Jupiter on March 5th, 1979. So it's good that it went from September 5th to March 5th. It's good that both of them are the 5th. So from September 5th, 1977 to March 5th, 1979, we have to figure out how much time has gone by. And they tell us the average distance, okay? And they want us to find the rate. So really, we're using distance equals rate times time. That's the formula we're using here. So we know our distance, and I'm trying to find the rate. And once I figure out how much time has gone by between September and March, then I'll know what time to plug in there for t. So I am trying to find the rate. So I could divide this equation by t on both sides. So now I have the equation for the rate. Distance divided by the time. And my distance is 390 million. So when I do this, I do have to plug in all the zeros to make it a million. Now the time. Okay, here's how we figure this out. From September 5th, 77 to September 5th, 78 would be 1 year. And then to go from September of 78 to March of 79, we'd have to figure out how much time had gone by then. So I know that for my time, I'm going to have 365 days for that first year. And then from September 1978 to March of 1979, we need to count how much time has gone by. So September to October is a month, November is 2, December is 3, January is 4, February is 5, March would be 6. So I'm going to have 365 days for a whole year, and then I'm going to have to add another 6 months or a half a year, which is 183 days. So I'll have about 548 days altogether. So my time then will be the 548. And when I divide those two out, I'll get 711,679. Now again, remember my distance was miles and my time is days, so this would be miles per day. So that is pretty fast, I would say. If you're covering 711,000 miles in 24 hours, that's really fast. Now, technically, the other way that you could solve this problem would be to use just distance equals rate times time and plug in your 390 million for your distance. We don't know our rate, but we are knowing what the time is. And then you would have to divide. So you could get the r by itself. And you would get the same answer. So your homework is going to have you focusing on solving the formula for the variable first and then substituting the information in. But if you substitute the information in and then solve the formula, you will still be doing the steps that the other method is using. But we really want you to focus on practicing solving a formula for a given variable. So tonight's homework is listed. Make sure you show your work, and if you have questions, come on in and see me before school.